morning, Bashu and all. Audible. Okay. Anything so far regarding yesterday class or whatever we have discussed in geography? Today's lecture we are moving towards atmospheric pressure, circulation of wind, different atmospheric pressure belts, yeah, different types of wind. First, understand atmospheric pressure. What does mean by this term atmospheric pressure? So this atmospheric pressure refers to force per unit area exerted by weight of atmosphere. Force per unit area exerted by weight of atmosphere. Generally, we measure it in unit Pascal, kilopascal, या bar, या millibar. Okay, MB. 1 millibar equivalent to 100 Pascal. Further, we can also denote a measure pound per unit inches, etc. So these are different units of atmospheric pressure. अभी बस ये डिस्कस किया है हमने atmospheric pressure. Force per unit area exerted by weight of air, generally measured in Pascal, kilopascal या millibar. Okay. क्या जाऊंगा मैं आज जाऊंगा और 1 नवंबर को रिटर्न हो जाऊं. कल की तो लीव है ना. हाँ. नहीं, परसों मॉर्निंग में वापस आ जाऊंगा. मुझे लीव बाद में लेनी पड़ेगी इस मंथ में. एक कलीग फ्रेंड की मैरिज है, तो फिर ज़्यादा छुट्टी हो जाएंगी, इसलिए अभी उनको वो किया जा रहा है. और वो भी बनारस में, तो काफ़ी डिस्टेंस पर जाना पड़ेगा. मतलब 2 दिन जो चाहिए. Now moving towards pressure gradient force. Pressure gradient force, या PGF. It refers to rate of change of pressure. It refers to rate of change of pressure with respect to horizontal distance. Rate of change of pressure with respect to horizontal distance. Okay, that is your pressure gradient force. Yeah, distance in horizontal directions. Yeah. हाँ, बसु है, अभिषेक है, ये जुझारू स्टूडेंट है। दीपावली को क्लास ले रहे हैं। हाँ, वैसे भी अगर क्लास शेड्यूल है पहले से, तो फिर वो घर पे ही क्या करना है। Now, generally, this pressure gradient force, you know, identified with isobars. What are the isobars? Isobars are imaginary line having the same pressure, having same atmospheric pressure. Suppose that atmospheric pressure at top of this digital board, suppose around this corner, atmospheric pressure 1000 MB. Suppose that around this point, same 1000 MB, around this point, this point, this point, this point, this point. So there is one imaginary line, it is isobar 1. ठीक है? It is isobar 1. Similarly, there may be very close to it 990 MB pressure. Suppose that these the dots which are connecting the pressure of 990 MB. हर्ट्स नहीं आ रहा है आजकल। चलो दीपावली में बिजी होगा। सो दिस इज आइसोबर 2। यस बसु, ऑलरेडी सेटल्ड। क्या? अच्छा अच्छा। हाँ ठीक है। सो आर यू गेटिंग दिस आइसोबर? हाउ वी आइसोबर डिफाइंस? Means it is not necessary that these are the parallel lines. These isobar line are just imaginary line having the same pressure. Okay, maybe your isobar 3 having 988 MB pressure, like that. Now closure will be the isobar, higher will be the pressure gradient force, PGF. Steeper are the isobars, yeah, very densely closely located are the isobar, steeper will be your pressure gradient force. Farther will be the isobar, lesser will be the PGF, pressure gradient force. Are you getting this? Okay. So generally in areas of high pressure, isobars are located spatially or closely. Closely. Okay. In areas of low air pressure, generally they are spatially located. Further, how much there is a change with respect to these isobars that determine your pressure gradient force. Okay, air likely to be move faster if there is more difference with the pressure along with horizontal distance in horizontal direction. Higher will be the difference of pressure between 2 points, larger will be the speed of wind, velocity of wind. Okay, because wind always move from high pressure to low pressure. If it will be larger, then there will be more speed of the wind. Now moving towards Coriolis force. Coriolis force. What do you understand by this force? Technically, it is not force, rather an effect. We call it Coriolis effect. And this Coriolis effect generally generated by rotation of Earth. Means as one body is started to move, then there is movement of inertia which is started to generate along with it. Similarly, along with Earth, there is inertia force which is started to generate. And this inertia caused deflection in the air. Because as Earth rotate on its axis, then atmosphere which surround the Earth's surface also started to move around. So there is deflection in this atmospheric wind, generally towards right hand in northern hemisphere, towards left hand in southern hemisphere. This Coriolis force caused deflection. It caused deflection in wind. Deflection in direction of wind particularly. Generally, it caused deflection in direction of wind towards right hand in northern hemisphere and towards left hand in southern hemisphere. Why it is so? Because Earth is rotating around its axis from west towards east, anti-clockwise. Okay, Earth is rotating like from west towards the east. Generally, it increases with increase in the wind speed. It is minimum at pole and maximum minimum at equator and maximum at pole. Minimum yeah, absent. Coriolis force. Are you getting this Coriolis force? That is why generally around the equator there is no development of low development of cyclones because there is no such rotation. Rotatory wind, yeah, inward circulation, outward circulation of wind is missing around the equator. Equator ke around we did not notice such kind of large cyclone in Indonesia, in Maldives, in some African country. Okay. Yeah, around Central America, yeah, this Brazil, Ecuador, Bolivia. In such region, we did not experience cyclonic storm. Ghana, Kiribati, we did not notice cyclonic storm because of absence of Coriolis force. Clear. But it is little bit difficult to understand. Wind deflected towards right hand in northern hemisphere, towards left hand in southern hemisphere. Now suppose that this is your equator, now 0 degree. This is your 30 to 35 degree north. This is 60 to 65 degree north. And here you have the 90 degree. Similarly, in south, you have 30 to 35 degree, 60 to 65 degree, 90 degree. Generally, around the equator, you have always high temperature. That's why there is low pressure. So we call them equatorial low pressure belt. Equatorial low pressure belt. Away from it, comparatively, you have lower temperature and higher pressure. And this is the subtropical zone. So we call it subtropical high pressure belt. Subtropical high pressure belt. Similarly, here comparatively you have lower temperature, higher pressure. We call it subtropical high pressure belt. Then in polar region, you have extremely low temperature and very high pressure. We call it polar high pressure belt. Polar high pressure belt. Similarly, we also called it polar high pressure belt because of extremely low temperature and high pressure. Polar high pressure belt. Now, in comparison to polar region, here you have lower temperature and you have higher pressure. We call this region as subpolar low pressure. Subpolar low pressure belt. These are different belts. Now, as per pressure gradient force, wind started to move from high pressure to low pressure. Okay, so equatorial low pressure 0 degree. Here you have low pressure, so wind will likely to be move in this way. Wind likely to be move in this way. Clear? Similarly, from high pressure to comparatively low pressure, comparatively you have lower pressure here. Wind started to move. क्या सबट्रॉपिकल हाई प्रेशर है? ये तो ठीक था. Okay. So wind likely to be moved from this high pressure towards low pressure like this. Further from polar region, wind likely to be moved like this. This is clear. Now, according to Coriolis force, generally wind deflected towards right hand in northern hemisphere, towards left hand in southern hemisphere. Clear? So just tell me, if wind is moving in northern hemisphere, wind is moving like this, or wind is moving like this from south towards north, whether wind will deflect towards A or whether wind will deflect towards B point in northern hemisphere. Towards A or towards B? If wind is moving from this region to this place, from S to N, south to north, okay, then wind likely to be deflected due to Coriolis force towards B or towards A. Online guys. Abhishek, what about you? Towards wind likely to be deflect towards right hand in northern hemisphere. Wind deflected towards right hand in northern hemisphere. Generally, you need to look towards the wind as per direction of wind. Your face should be in the direction of wind. So our right hand is like this, wind is moving like this. Wind will be deflected towards right hand. So if wind is moving like this, wind will be deflected in this way. Clear? Okay. Here you have the equatorial low pressure belt, high temperature, low pressure. Okay. In comparison to it, around 30 degree, generally you have high pressure because of low temperature. So wind likely to be moved from subtropical high pressure towards equatorial low pressure. Yes. Subtropical high pressure towards equatorial low pressure. Clear? Okay. Now, from subtropical high pressure belt, look, compare 60 degree, 65 degree north. Generally, here you have comparatively lower pressure in comparison to polar region. Here you have the lower pressure. So wind likely to be deflected from subtropical high pressure towards subpolar low pressure. Towards subpolar low pressure. Okay, if wind is moving like this, due to Coriolis force, it is likely to be deflected towards right hand. What is mean by pressure? Pressure is nothing, force per unit area को ही तो pressure बोलते हैं. पूछो. Force per unit area means force exerted by air. Air भी तो force exert कर रही है. वो atmosphere pressure, pressure exerted by atmospheric air. We call it atmospheric pressure. ठीक है. After that, you will notice that generally here 90 degree you have high pressure, extremely high pressure. Wind likely to be moved from high pressure regions towards low pressure, subpolar low pressure. Okay. आपको अगर कोई डिफिकल्टी हो तो मैं लिख देता हूं सबपोलर लो प्रेशर बेल्ट ये पोलर हाई प्रेशर है क्या हाँ ये सब ट्रॉपिकल हाई प्रेशर है ये इक्वाटोरियल लो प्रेशर है। सिमिलर इन साउदर्न हेमिस्फीयर सेम है। सब पोलर लो प्रेशर बेल्ट, सब ट्रॉपिकल हाई प्रेशर बेल्ट, पोलर हाई प्रेशर बेल्ट। ठीक है, सो विंड ऑलवेज मूव फ्रॉम हाई प्रेशर टू लो प्रेशर। क्लियर? अब यहां पर आपका लो प्रेशर है, यहां पर हाई प्रेशर है, यहां पर लो प्रेशर है, यहां पर फिर से हाई प्रेशर है। सो विंड इज मूविंग फ्रॉम पोलर हाई प्रेशर टू सब पोलर लो प्रेशर। Wind is moving from subtropical high to subpolar low pressure. Wind is moving from subtropical high to equatorial low pressure. Wind is moving from subtropical to equatorial low pressure, southern hemisphere. Subtropical high pressure to subpolar low pressure, and polar high pressure to polar low pressure. Now we need to check the direction of wind. Wind deflected towards right hand in northern hemisphere, towards left hand in southern hemisphere. Okay, so wind likely to be become westerlies here in between 30° north to 60° north, near about. Okay, what will be direction of this wind? In northern hemisphere, if wind is deflecting downward, means what will be the direction, whether it will be move towards A, towards B, towards right hand. अच्छा, ठीक है, मतलब उसका अपोजिट आपने कर दिया है। ठीक है, इसमें ए साइड में होगा बिकॉज माई राइट हैंड इज हेयर दिस साइड एंड माई फेस इन द डायरेक्शन ऑफ एरो, एरो ऑफ विंड। ठीक है, हेयर माई फेस इन डायरेक्शन ऑफ एरो, माई राइट हैंड इज दिस। आर यू गेटिंग? सो विंड likely to be deflected in this way, wind likely to be deflected in this way. Now southern hemisphere में just opposite होगा, wind left deflected towards left hand. So wind deflected towards left hand, wind will be deflected like this. My face is in the direction of arrow and will be deflected towards left hand. ठीक है? Here, what will be the direction of wind? Towards left hand. Simply, direction will be towards left hand. Are you getting this? So here, you have direction. Generally, these winds are called as northeast trade wind. These winds coming from southwest direction, so southeast trade wind. Here you have the westerlies. Here also you have the westerlies. These are polar easterlies. Because deflection likely to be more, very high in polar areas. So these are polar easterlies. Westerlies means wind coming from western side. Polar easterlies means around poles wills wind move coming. हमेशा जहां से रिवर ओरिजिनेट हो रही है, हमेशा जहां से विंड ओरिजिनेट हो रही है, आ रही है, उसी के डायरेक्शन के अकॉर्डिंग वी नेम, एंड उसी के डायरेक्शन के अकॉर्डिंग वी जनरली फॉलो लेफ्टवर्ड या राइटवर्ड। आप जहां से मूवमेंट स्टार्ट करते हो, तो करोल बाग में मतलब सपोज दैट इफ यू आर कमिंग या यहां से कहीं जा रहे हो, तो लेफ्ट या राइट यू कंसीडर एज पर सोर्स ऑफ source of origin या place from where you are moving onwards. ठीक है, डेस्टिनेशन के अकॉर्डिंग तो आप नहीं करोगे राइट या लेफ्ट, जनरली सोर्स के अकॉर्डिंग करोगे जहां से आपका स्टार्ट हुआ है. ओके, क्या क्वेरी था आपका? सो विंड कमिंग फ्रॉम वेस्टर्लीज, वेस्ट डायरेक्शन. Wind coming from polar easterlies, east direction. Wind coming from northeast, northeast trade wind. Wind coming from southeast, southeast side. Okay, they are moving from northeast to southeast. They are moving from southeast to northwest. ठीक है. So how these winds are moved? Now are you able to understand? Can you tell me why Coriolis force? Although such question has not been raised by different competitive examination, but still for better clarity you should understand why Coriolis force is minimum or absent at equator and max at pole. ऐसा क्यों हो रहा है? Why wind deflected more towards polar region rather than equatorial region? It means just like this is your earth, it is your earth. लूज हो गया इसका. Okay. If it is rotating around its axis like west to east, so air which is situated above it, situated on top of it, likely to be deflected along with it. It deflected more towards pole, it deflected less towards the equator. Why it is so? ऐसा क्यों हो रहा है? Means there is envelope of air around this earth. There is surrounding air. When this earth is rotating on its axis, then air will likely to be deflected. Okay. So it is minimum deflection around the equator, maximum around the pole. How it is so? Look, this is your earth. This is your equator, 0 degree. Okay. Now consider point here. Let's suppose point A is at equator. Let's suppose point B around 30 or 40 degree. Suppose around 30 degree north. Clear? If you throw a ball from this place to that place, अगर आप एक ball throw करोगे, then ball will not move like this. Rather, the actual path of ball will be like this because Earth is rotating on its axis. Similarly, suppose that there is a point here. Consider it is y, and there is a point here x. Suppose meridian is same, means longitude is same. Now you throw a ball. You throw a ball from this region to that region. This ball will not follow this path. rather it will be deflected more. Are you getting this? So deflection likely to be more at this place around the polar region. Look how technically it is happening. Suppose that not only ball, if you want to shoot your enemy, which are placed at particular region. Suppose that you want to fire a missile from India to London, या इंडिया के जस्ट एबव में एक सेम मेरिडियन पर कंसीडर करो एनी पॉइंट रशिया ओके ये डूडिंग का कुछ कोई अच्छा प्लेस नहीं मिल रहा है कुछ भी suppose that if you want to fire a missile from India to Dudinka in Russia, okay, now both are located around the same longitude, but if you will target just you know just exact point, yeah, the same meridian, your missile will not hit the target, it will miss the target. Suppose that there is a merry-go-round. Consider this is merry-go-round. Merry-go-round देखा है ना, स्कूल वगैरह में प्ले किया होगा या गार्डन में. दिस इज मैरी गो राउंड. ठीक है, क्या बोलते हो इसे, झूला, गोल गोल झूला. Okay, suppose that this is moving around, turning around like this from west to east. Okay, if you are sitting here and your opponent sitting here and you want to throw ball from this place to this place, या you want to shoot fire him, ठीक है, मूव होता रहेगा तो नहीं लगेगा. आप इमेजिन ऐसे कर रहे हो लेकिन एक्चुअल पाथ इसका ऐसे होगा. ठीक है, तो आपको वो साइन एंगल कैलकुलेट करना पड़ेगा, एंगुलर डिस्टेंस. सो यू आर टारगेटिंग लाइक दिस बट एक्चुअली इट इज मूविंग लाइक दिस. हाँ, क्लॉकवाइज और एंटी क्लॉकवाइज वो डेफिनेटली. ओके, सिमिलरली if you will throw ball from this region, then it likely to be deflected towards this region. So that is how direction of wind occur, या move, या deflected, या change in northern hemisphere, southern hemisphere. Okay, direction of wind. Hope this direction is clear to you. Now coming towards this point that the question raised by me, why it is minimum at equator, why it is maximum at pole. क्यों मिनिमम होगा, क्यों मैक्सिमम होगा? Because the rotation around the equator is maximum and rotation around the pole is very minimum. So there will be more deflection around the pole. Just consider this merry-go-round, etc. देखो ये फील होता है अपोजिट, लेकिन टेक्निकली देखो यहां से अगर आप इस डायरेक्शन में मूव करोगे, ठीक है, सो likely to be deflected less. But when you move the ball inside the axis, because axis, suppose that this is the axis of this merry-go-round here of Earth, entire Earth, so it is just turning around. It is just turning around. So angular movement likely to be higher at this place. Linear distance likely to be less, but angular movement is higher at this place. Yes. Linear distance likely to be maximum around the periphery, around the equator region, but angular distance likely to be less. Angular movement likely to be less here. Okay. So there will be more deflection because it is around the axis. Suppose that in 24 hours there is almost negligible movement. यहाँ पर क्या हो रहा है, इसी के अराउंड में टर्न कर रहा है, and here within 24 hours there is one circle completed. Okay. So deflection of wind, suppose that wind is just stationary above it, the deflection likely to be caused higher here, deflection likely to be caused lesser towards outer periphery. It looks like opposite, but technically how it occurs. Okay. Anything, Basu? Temperature, pressure. Any confusion in temperature, pressure? This clear? So we have maximum speed around maximum deflection of wind around the pole and minimum deflection around the equator. ठीक है? Otherwise, you can just remember it, or you just go to merry-go-round and look how the difference is created. ठीक है? So wind get deflected towards right hand. In northern hemisphere, wind get deflected towards left hand in southern hemisphere. Done. Okay. Now moving towards pressure belt. So equatorial pressure belt, we call it doldrum. We call it doldrum. Doldrum means zone of calm. Doldrum means zone of calm. Okay, such question already raised in different competitive examination. It is zone of calm. Why it is zone of calm? Because of absence of Coriolis force, generally wind rises just above the equator. Wind are rising just above the equator, and there is consolidation. Yeah, you can say conventional type of rainfall. Around the equator, wind are just rising, and wind gets saturated, maybe around 12,000 meter distance per maximum. Up to 12 kilometer, wind gets saturated, and then there is a precipitation. There is a rainfall, continuous rainfall. कहाँ बिजी चल रहे हो? हाँ? बोल दो, यूं 5-10 मिनट बात कर लेंगे. ठीक है, इक्वेटोरियल लो प्रेशर बेल्ट. सो विंड जनरली राइजेस फ्रॉम दिस लैटिट्यूड up maybe up to 12 kilometer, and there is a rainfall, and rainfall is almost continuous throughout the year in equatorial region, maybe around 10 degree north and south of equator, up to 10 degree north and south of equator. There is a more rainfall in अंडमान एंड निकोबार इन इंडिया, ठीक है. Kind of tropical evergreen forest, good amount of rainfall. Good amount of rainfall in Indonesia, Malaysia, या मालदीव. हाँ, मौसिन राम वहाँ भी अच्छा है, चेरापूंजी वगैरह में. हाँ, अच्छा रेनफॉल होता है नॉर्थ ईस्टर्न इंडिया में. स्टार्टेड फ्रॉम मे ऑनवर्ड्स एंड कंटिन्यू टिल सितंबर. वेटलैंड, हाँ, वेटलैंड ऑफ नॉट ओनली इंडिया बट ऑल्सो वर्ल्ड. ठीक है, वो मानसून में डिस्कस कर देंगे. ओके, नाउ these went further when rises to high altitude, then due to rotation of earth they are deflected towards subtropic high and upper atmosphere, and these dry wind generally started to descend around subtropical high pressure belt, which further intensify high pressure. So over ground, wind started to move from subtropical high pressure towards equatorial low pressure, and they are deflected towards right hand, means northeast trade wind या southeast trade wind. Now, because lot of cool dry wind are descending, so generally the pressure likely to be higher at this place. Pressure remain high at this place. Okay. Now from high pressure, wind started to deflect it towards subpolar low pressure. Even pressure here at 30 to 35 degree north is higher than 60 to 65 degree north. Generally, technically, pressure should be low, around 60 degree, because generally comparatively temperature is low, around 60 degree. But due to these equatorial wind which rises and freeze become very cool, dry, when descend around subtropical high, then they intensify this pressure. Okay, because just above the equator around the tropopause you have lesser temperature than polar region. Around the tropopause at polar region you have 40 to 45 degree negative temperature, but above the equator around the tropopause you have minus 80 to minus 100 degree Celsius temperature. So when these very cool dry wind descend around subtropical high, they create high pressure. From high pressure, wind started to move towards equatorial uh, low pressure. Yeah, wind started to move towards subpolar low pressure. So these winds get deflected towards right hand, means from west towards east. So these are called as westerlies. These are called as westerlies. Similarly, in southern hemisphere, from subtropical high, these are winds called as westerlies. Similarly, wind move from high pressure in polar regions towards equatorial, towards subpolar low pressure, and their direction is polar easterlies. Clear? Okay. Now, moving towards different types of wind here. Before that, this is called as doldrum. Now, this is horse latitude. Around 40 degree, we have this horse latitude. Why this is called as horse latitude? Why this is called as horse latitude? This is called as horse latitude because during medieval time period, particularly from 15th century till 19th century, there was huge trade of horse. Okay. We call these winds as southeast trade wind and northeast trade wind because these winds were very helpful in trade. What kind of trade? Trade in spice, and trade was more popular in horses because earlier good quality of road were not available. Further, the availability of motor, engine, etc. started towards 19th century. And between 15th and 19th century, generally horse were utilized for fast movement from one region to another region. So there were huge trade in horse, and best breeding quality of horse generally found yeah, prepared in Spain and some surrounding European countries. So Spanish people who also achieve good skills in movement, trade, okay, horse breeding, etc. They started to sail these horses across the globe, especially for military purpose or especially for various king and princes. They started to trade these good quality of horse. Now, because of high pressure condition, wind become very slow in this region. Generally, during high pressure, in winter you have high pressure, so wind become very slow here. Slow winds. Now, when wind speed reduces, then sometimes voyage of these Spanish, Portuguese, and some European people just stuck around 40-degree latitude. Then they have no option. After waiting for weeks within the oceans to move forward, yeah, backward, they did not find any options rather to lighten their weight of the ship so that the stuck ship can move from such region. Because the only source for available for ship movement was winds. So when wind were very poor, slow in such latitude, then they generally used to throw their horses inside the ocean. Although in this process they also lose huge revenue, yeah, there was huge loss, but to protect themselves, to protect drinking water, to protect available food, etc., and to move from that region, they have no other options. Rather, they need to throw horses. नहीं तो उसमें कर्टेन्स होते हैं, पायरेट्स ऑफ कैरिबियन वगैरह देखा है आपने? उसमें कर्टेन्स होते हैं। सपोज दैट शिप के इस साइड में कर्टेन को अप करना है या आगे साइड में कर्टेन को अप करना है। अगर विंड इधर से आ रही, ठीक है, और आपको उधर जाना है, लाइक दैट, सो किस डायरेक्शन में कितने एंगल पर कौन सा कर्टेन अप या डाउन करना है, लाइक दैट। Generally during season wind also get change, so they also plan their journey according to change in the season. Sometimes definitely they obstructed या go या miss their target. That's why Columbus reached to America rather than India. ठीक है, because of poor availability of map या less availability of technical instrument. आजकल तो सैटेलाइट से सारा कुछ डाटा पता लग जाता है, या इंफॉर्मेशन दे हैव एडवांस इंस्ट्रूमेंट getting the direction, identifying the locate particular latitude, longitude. Okay, at that time there was no such common consensus, there was no such availability demarcation of various landmark. ओशियन में चारों तरफ पानी पानी दिखता है, so sometimes they also go astray and they need to wait for change in the direction of wind after changing in the season. Okay, otherwise they need to change their route, or they generally shape wind या यूटिलाइज विंड थ्रू देयर कर्टेन्स, ठीक है, तो उसको चैनलाइज कर लेते थे। उस वे में they likely to be little bit receive help from winds. Okay, so this was popularly known as horse latitude, and in this process they lose lot of revenue. Means these were some of the most popular trade routes that existed earlier from European countries to American countries. Still, this Atlantic Ocean is the world's busiest ocean since medieval century. This is how they used to, you know, load in, yeah, out inside the voyages. Yeah. तो कैसे मूव करोगे इनसाइड से? अभी अभी भी प्रोडक्ट कैसे पोर्ट से आप आउट लेते हो? शिप तो एबव लैंड कैन नॉट कम। तो आपका रास्ता क्या है? अभी भी जो कंटेनर्स होते हैं, लार्ज कंटेनर्स या हॉर्सेज, अभी भी ऐसे आता है। या अब तो बॉक्स वगैरह में पैक करके और आप कंटेनर को उससे ऑटोमेटिक हाइड्रोलिक मशीन वगैरह से ले आते हैं, मूव कर देते हैं। या दिस इज वेरी नॉर्मल एक्सरसाइज, वेरी कॉमन एक्सरसाइज, पुली को यूज करके। ठीक है, सो दे यूज टू थ्रो द हॉर्सेज इनसाइड द ओशियंस एंड आफ्टर a few days they likely to be die within the ocean. What they will do? Hmm? There was no option. आपका अगर सिप हैवी है, लोड है, it will not move. It require heavy wind. In light wind it cannot move. ठीक है, so to lighten their ship, to reduce load, to move from that stuck place, from high pressure region, they used to throw horses inside the ocean, and anyhow they survive themselves. To protect drinking water, you cannot store infinite drinking water, and within the ocean all around you have the water, but there is no drinking water. Further, you have limited amount of food items as well, and your life is also important. Horse can be breeded further. Next trade can be more beneficial. दूसरी trade से the loss can be recovered. Okay, like that, because they. But gradually, these voyagers etc. understand. Generally, after losing their revenue, yeah, horses multiple times, they learned that something is not suitable in this region. This region is dangerous, and do not go inside this region because there is no wind in this region. But such kind of geographical understanding they did not have because of high pressure condition. Winds become very slow in this region. No, after that they learned. एक बार आपको भी लॉस होगा तो सब कुछ क्लियर हो जाएगा कंसेप्ट. Are you getting? So after experience, later on, geographer, you know, explain why winds are slow here. Okay, now moving ahead. This is the question this year has been raised. पशु। What will be answer? दोनों। ओके। देखो, जब आपकी विंड वेलोसिटी ज्यादा होगी तो डिफ्लेक्शन फास्ट होगा। यस और नो? जितना ज्यादा स्पीड होगी उतना ही ज्यादा डिफ्लेक्शन होगा। यस। जितना फास्ट बॉल होगी, विंड की स्पीड डिपेंड ऑन प्रेशर ग्रेडियंट फोर्स, जितना डिफरेंस होगा प्रेशर में बिटवीन टू पॉइंट, यू हैव मोर स्पीड। बाई ट्यूब से हवा एयर जो आउट होता है वो कैसे होता है? मोर डिफरेंस इन द प्रेशर। या ट्यूब में इनसाइड जाता है प्रेशर से। जितना ज्यादा डिफरेंस होगा प्रेशर में, एक सिलेंडर गैस सिलेंडर से दूसरे में जाता है, कैसे जाता है? हाई प्रेशर टू लो प्रेशर। जब प्रेशर बराबर हो जाता है तो गैस मूव ही नहीं करता है। यस। जब तक गैस मूव करता है जब तक कि प्रेशर बराबर ना हो। फिर वो लोग क्या करते थे? नहीं। हाँ। हाँ, एयर को रिलीज करते थे ताकि स्पेस बन जाए, और दूसरा फिर वो नए सिलेंडर से जिसमें ज्यादा प्रेशर रहता था उससे फिर गैस इंसर्ट करते थे। ठीक है, वो मैकेनिज्म। सो बोथ आर करेक्ट। इंक्रीजेस विद इंक्रीज इन वेल्ड वेलोसिटी। आई हैव ऑलरेडी यू नो नोट इट डाउन। ये लिखा हुआ है ना पहले आपका, इंक्रीजेस विद इंक्रीज इन विंड वेलोसिटी। स्टार्टिंग में ही ये डिक्टेट किया था, मतलब नोट पॉइंट मेंशन किया था। increases towards pole, increases with increase in the wind speed. Now moving towards various kind of wind, types of wind. Number one is doubt clear, Basu. First one is planetary and permanent wind. Second is periodic winds. Third one is local winds. These are three types of wind. Now planetary or permanent wind. Planetary or permanent wind generally existed throughout the globe. Generally, these remain permanent, blow continuously throughout year, around whole year. And move in definite direction. क्या? हाँ बिल्कुल होगा। टाइप्स ऑफ विंड, हैंड आउट में सारा कुछ अवेलेबल है जो भी मैंने अभी तक डिस्कस किया है। पिछले हैंडआउट में भी सब कुछ अवेलेबल होगा. Yes or no? Trade winds. So we have northeast trade winds and we have southeast trade winds. Why they are called as trade winds? हाँ, planetary winds का part है. First one is trade wind. Okay, trade wind, northeast trade wind and southeast trade wind. These planetary winds can be further divided. They can be further divided into trade winds, westerlies, and polar easterlies. These northeast trade wind or southeast trade wind, they are called as trade wind because they were highly helpful in trade, especially during medieval time period when there were absence of steam engine. Okay. Then second type of winds are westerlies. Within permanent wind, you have westerlies. So westerlies move. Westerlies move from around 30 to 35 degree north to 60-65 degree north. In northern hemisphere, from west towards east. In southern hemisphere, from west towards east, between 30 to 35 degree south to 60 to 65 degree south. These are westerlies wind. Now these westerlies wind are very strong during in southern hemisphere. Can you imagine why westerlies are more strong in southern hemisphere? Than northern hemisphere? The reason is because of more presence of water bodies, because absence of land mass, absence या low land mass. So wind likely to be run faster over the ocean, over the land mass. कहाँ पर ज्यादा strong wind मिलती है? Oceans में. Because of absence of obstruction. Because there are no barrier. Above the land you have the mountains. Above the you land, above land you have various kind of buildings, trees, forest. Okay, various kind of obstructions, which reduces a diverted momentum of the wind, which reduces their speed and change their direction. But there is no such barrier and there is no upland downland over the ocean. Ocean have same level. So that's why in absence of barrier, there are very, very strong winds. Because of their strength, these winds are known as around 40 degree latitude. These winds are known as roaring 40s. In southern hemisphere, these winds are known as roaring 40s. Why they are known as roaring 40s? Because they are moving around 40-degree south latitude, because when these winds are moving, then they cause very large noise or sound. Low land mass. Because these winds create large noise or sound, and because of this sound, these winds are called as roar. Means they started to roar. जैसे lion roar, दहाड़ना. Similarly, when wind is stuck with curtains with shape, then there is very large sound noise, just like roar. So that's why we call it roaring 40s. Okay. And some of the competitive examination, these winds are also asked. Yes, several question has been raised. Then there are furious 50s. Furious 50s. Because these winds are blowing in southern hemisphere around 50 degrees south, and they are more dangerous than roaring 40s. Roaring 40s speed may be around 50 kilometer per hour to 100 kilometer per hour, but their speed further increases maybe up to 120 kilometer per hour to 150 kilometer per hour. So that's why they are creating furious condition. Further, in southern hemisphere around 60-degree, you have very low land mass and there is more de- decrease in the temperature. So when boys move from this region, then they experience very cold, chilly winds along with very severe high speed winds. So that's why they are called as furious 50s. Further, they are called as screaming. They are called as screaming 60s. बस ये लास्ट कर दे रहा हूं मैं. Screaming 60s, because these winds are located around 60-degree latitude. Further, this is extremely challenging latitude. If voyagers can protect themselves from these winds, then we can say that they have good skills, capacity, or potential, or courage by passing their voyage from this latitude. Okay. Further, the temperature become quite freezing here, and the wind speed may increase up to 180 200 kilometer per hour. So that's why it is known as screaming 60s. Another third type of planetary wind is polar easterlies, which move from eastern side in polar region. ठीक है. Periodic wind tomorrow means on 1st November. 2nd November you have a test. ठीक है. Okay, Bashu. Same to you. Happy Diwali, Bashu. Welcome you guys. Bye bye.